recording me?
I was trying to stay out of people's pictures.
Yeah.
It was already in them. So.
Stop it and start it. Hello everybody, welcome to Brockway Mountain. We are near the top, not that much below. I wanted to get away from the people when I do this. Let's give a quick orientation here. First, we are in the Upper Peninsula of Michigan. The water body's Lake Superior, that's what you see there. And you'll see these hills that gently dip this way and then drop off this way. I'm going to explain those in a minute. But first I want to talk a little bit about the glacial setting here, because this was glaciated. Now, the slow dipping, the glaciers came from this way, okay? That way south, all right? So as they came over, the dips that you see there, they would have just plucked and moved and over on the side, and then you see how it drops off. Well, it drops off here like that too. That's because they got to the other side and they would just scour it out. And then later streams form. Upton Creek is down here. But there's something here. This valley is here for another reason too. But first I just want to point out, you see Donut Lake in the background there, the little island in it. That's not what it's called, but that's what we call it. These lakes here and this creek are near contact. You have the Portage Lake volcanics where most of the trees are over there, and those hills in the background. And what we're standing on is Copper Harbor Conglomerate, the basal conglomeratic unit of the Big Continent Rift once the rift failed. For whatever reason, we have a couple hypotheses, but the rift, when it did fail, the magma chambers emptied and the land subsided. And this was the first formation of the Oronto group to be deposited. We know its age. The youngest Portage Lake volcanics near the top, almost exactly at the top, that have been dated are 1,091 million years old. There are lava beds within here, and you can see them as you drive up from the west, a couple of them, but you'll mostly see conglomerate exposed in the on the way up. But those are called the lakeshore traps informally. I did name them in 2016. They're about 1,087 million years old. And then above that we have the Nunsuch Formation, which is mostly siltstone, shale, fine sandstone, lake deposits. And that's been dated at about 1,085 million years ago using some, not zircons, I forget the technique, but anyway, it doesn't matter. There's no lava units known in the Nunsuch. And then above that's the Frida. So we have this thing bracketed between 1,091 and 1,085 million years ago. And all these units in our tongue, so we know there's no real unconformities here. I think another age in the Nunsuch that came up is 1,081, I think is another one. But anyway, so that's, the point is, it didn't take a long time to deposit this unit, which is a couple thousand feet thick in places. So what you see is pretty much the contact between the volcanics and this here. Now, you can see here's some of the pebbles that weather out of it. They're pretty much the Portage Lake volcanics. There's no granitoids in here or anything like that. In some places where it was near the granitoids, there are a couple, but it's almost all basaltite from the Portage Lake volcanics. And it's interbedded with sandstones and things like that. And there's a couple of lava lenses or tongues that come into the base of this that outcrop near the Monk's Jam place. Yeah, whenever you define this, I went all over here, and you just see the cliff just drops. And I didn't do any rappelling, but it's the outcrops are here, and they are decently exposed. A lot of Precambrian geology in this area, and like I said, this is just one of the interesting places because this is where the Mid-Continent Rift died. Anyway, that's it. If you have any questions or comments, please leave them below, and I hope you learned something.